Scenario analysis is a process of analyzing possible future events by considering alternative possible outcomes. Scenario analysis is not prediction. It does not try to determine what the future will be with any degree of accuracy. Rather, scenario analysis focuses on determining and analyzing a subset of plausible combinations of events and pathways that are of interest to decision making. In this project, we will implement scenarios in the DRFEWS model. Scenario analysis typically includes a baseline scenario that reflects practices, trajectories that maintain business as usual or what are deemed to be the most likely set of conditions in the future. For example, a baseline scenario could be constructed based on the present globalized system of trade and unabated greenhouse gas emissions. We are interested in understanding how the systems and sectors related to food, energy, and water could be affected by various plausible events. These events could occur within one of these systems. For example, technological change could substantially alter the costs of fossil fuels such as coal, natural gas, and oil relative to renewable energy such as wind, solar, or geothermal. Events could also originate from outside a system but have an effect on it. For example, a tariff could decrease trade and affect the demand for soybeans. An event could also affect two or more of the systems, such as restrictions on fertilizer application that is intended to reduce the environmental consequences of runoff. Such regulation might reduce harmful algal blooms, but it could also affect the productivity of farmland. And events can have effects that propagate through the systems. For example, a prolonged drought would reduce the availability of water, which would reduce agricultural productivity, cause farmers to implement more efficient irrigation systems or to switch to more drought-resistant crops, either of which would affect costs. And the availability of water for cooling power plants would decrease, alter the mix of facilities that are dispatched, and also affect costs at the same time that demand increases. There are a number of drivers of changes or elements to the scenarios that can contain, including changes that originate from the rest of the world, regional or local shocks, trends that change consumer preferences, policies and regulations, technological innovation, and many, many more. Our goal is to take the scenarios, implement them in the DRFEWS model, and seek to understand the effects on food, energy, and water systems in the U.S. Midwest, in order to understand the potential implications of trends towards deglobalization on these vital aspects of modern society, and work with policymakers to mitigate their negative consequences.